Hi guys, welcome to my channel, The Analyst. Today we'll basically look at how we can remove outliers using Grubbs test. So let's get started. Right. As usual, I have my first few steps wherein basically I clean up my environment and I load the library. Here we'll be using the Outliers library. To read more about the Outliers library, you could basically use the help. Right, and since we're using Grubbs test, basically click over here and you can read through. Now the next step that we'll do is basically we will read in the crime data set, right? The only now basically we'll be checking for outliers for a particular feature, and over here I've decided to pick up the crime column, right? So this is the data that we've read in. I will attach the link to the data set in the description. So I'll be looking at the crime column. There are 47 observations in this data set. Now, like I said, we will only be performing the test on the crime column. So I isolate that column and then I plot a histogram to check whether the data in that column is normally distributed. That is a prerequisite for Grubbs test, right? We'll not be able to run Grubbs test if the data is not normally distributed. As you can see from the histogram, pretty much it's like a bell curve, right? So it's pretty much normally distributed. So I think it's good to say that we can move ahead with using Grubbs test. Now, in order to check exactly which are outliers, we will basically do a box plot, box whisker plot. Right? If you can see on the crimes column, I do a box plot, and this is basically the that I have over here. Okay. These points over here basically mean that 50% of your data lies between around the 700 range to somewhere around the 1100 range. Okay, so they're more concentrated over here. And then you have your data that's around the 200 range to this thing, which is basically 0% to 100% of your data. We can also see that there are outliers over here. Now, one thing to note that we should always know exactly what that outlier means, because we can't always say that it happened by chance. Probably there was some kind of logic as to why that data point is different compared to the rest of the set. Okay, in such cases maybe it may not be in our best interest to get rid of the data. However, in this case, let's go ahead assuming that this is an outlier and we need to get rid of it for the sake of the STEM. Okay. Now I'm using Grubbs test over here and I'm using type 11. Why type 11? Type 11 is basically used to check whether there's an outlier on both sides. Okay. Once I run it, what I can see over here is that my p-value is 1. Okay, p-value of 1 is not a strong indicator that the outlier is actually on both sides. So let's check. From the plot we can see that the outlier is actually on one side. Okay, so now we'll use type 10 to check if the outlier is just on one side. Here I've used Grubbs test again with type 10. Type 10 is basically Grubbs test for one outlier, and here I have a p-value of 0.07. So that's a pretty good p-value, indicating that there does exist an outlier on one of its sides. Then I basically plot a summary. And now the thing to note over here is that we need to remove these outliers out, right? So we will have to establish some kind of a benchmark over which data beyond it is removed. Okay, so that's what I do over here. Establish a benchmark, and 1656 basically is my benchmark, and I remove any data beyond 1656. Now when I check the summary, my max is at 1635. Now I box plot again the new dataset after removing the outliers, and here basically is my plot. I check again, single-sided outlier type 10, right, on basically the new data set after removing the outliers, and I get a much better p-value. Again, I would like to reiterate that you should always know what points you're removing out of your data set and only treat them as outliers. Remove those outliers if it does not make business sense or it happened by chance. Alright guys, thank you.